Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. As usual, we first come to its statement. This problem is about thermodynamics, thermal energy. Okay. When you turn on the hot water to wash dishes, the water pipes have to heat up. How much heat is absorbed by a copper water pipe with a mass of 2.3 kilogram when its temperature is raised from 20 degrees centigrade to 80 degrees centigrade? Okay, we have to find out the heat which is absorbed by the copper water pipe. Okay, two things are given. First thing is the mass. Okay, mass is 2.3 kg while temperature is final temperature 80 degrees centigrade and initial temperature 20 degrees centigrade. So 80 minus 20 equal to 60 degrees centigrade. That is delta T. Change in temperature is equal to 60 degrees centigrade. Dear students, moreover, the formula which we are going to apply in order to solve this problem contains specific heat. Okay, which is a constant, and this constant will be taken from table of physical constants. Okay, dear students, this is a table of physical constants. Specific heat of common substances, material, then specific heat in terms of joule per kg into Kelvin. Kelvin temperature. Okay, unit of specific heat is joule per kg into Kelvin. Copper is given at left column on fourth row. Okay, copper 385 joule per kilogram Kelvin. This is the specific heat of copper. We will take this value from this table. Okay, copper left column and fourth row. Okay, copper 38 joule per kilogram Kelvin. Dear students, it is also important to note that Kelvin scale and Celsius scale are different. We have to add 233.15 when we convert Celsius scale to Kelvin scale. But here we are not going to convert Celsius scale into Kelvin scale, because magnitude of 1 Kelvin and 1 centigrade is equal. Okay, so dear students, this is the formula which we are going to apply. Okay, this formula, two versions of this formula have been shown here. Okay, heat transfer Q is equal to mc delta T. Delta means change, delta T means change in temperature. This alternatively becomes equal to M capital C into Tf minus Ti, where F and I are written as subscripts of T, that is final temperature minus initial temperature, that is change in temperature. Okay, heat transfer is equal to the mass of an object times means multiplication, times the specific heat of the object, times means multiplication, times the difference between the final and initial temperatures. Okay, The same formula has been given in another form below this formula, that is Q is equal to mc delta T, where Q is heat required to change temperature of a certain mass, M is the mass of material, C is the specific heat of material which we have taken from table of physical constants, and delta T is temperature change, that is Tf minus Ti, final temperature minus initial temperature. Dear students, this is another fact about Kelvin and Celsius. Okay, we will also see this. Okay, by definition, the units of the Celsius scale, symbol C degree, centigrade degree, degree centigrade, degree Celsius, and the Kelvin scale have the same magnitude, that is a rise in temperature of 1 Kelvin and a rise of 1 degree centigrade are both equal to 1 Kelvin. And any temperature in degree Celsius can be converted to Kelvin scale by adding 273.15. But here we will not convert this Celsius into Kelvin, because in magnitude 1 Celsius and 1 Kelvin are equal. Okay, this is the formal solution of this problem. Okay, first, dear students, first is the given formula. Okay, which formula? Q is equal to mc delta T. M mass is provided in the problem statement, which is 2.3 kilogram. C specific heat has been taken from the table of physical constants, which is 385 joule per kilogram into Kelvin. And then delta T, that is final temperature minus initial temperature. Final temperature is 80 degrees centigrade and initial temperature is 20 degrees centigrade. So 80 minus 20 will become 60 degrees centigrade. Now, dear students, kilogram will be cancelled with the kilogram, and C, that is degree centigrade, will be cancelled with the Kelvin, because we have already explained that in magnitude 1 Celsius, 1 centigrade and 1 Kelvin are equal, because here we are not going to convert Celsius scale into Kelvin scale. We are just taking the magnitude of unit of Celsius and of Kelvin. Okay, so kilogram will be cancelled with kilogram and degree centigrade will be cancelled with Kelvin, because both are units of temperature, and our answer will become only in joule, because unit of heat is joule. So we will get 2.3 into 385 joule per Kelvin into 60 degrees centigrade, and this becomes equal to 53,130 joule. Okay, because Kelvin and degree centigrade will be cancelled and we will get only joule. We can rewrite this quantity, that is 53,130 as 5.3 into 10 raised to the power 4 joule. Okay, we can also write it as 53 into 10 raised to the power 3. Similarly, 531.30 into 10 raised to the power 2 or 5313.0 into 10 raised to the power 1 joule. Okay, so these are different styles, but this is enough. This is most suitable. 5.3 into 10 raised to the power 4 joule. This is the reference book, and this is the end of our problem. This is the end of our video. Till next problem, till next video. Allah Hafiz.